Hi, Assalamualaikum. My name is Nur Ain Mardia binti Muhammad Yusri in a group of J4EM1104L. Today, I'm going to do a presentation about Lab 1 turning for Mem360. Okay, so here is the question that I received for this lab experiment. So as you can see, this workpiece is made from aluminum alloys, and I'm going to do a presentation about one of the machining process in this turning operation, which is rough contour. So before I explain more, I'm going to show you guys a video of me doing this process, which is rough contour. Okay, so based on the video earlier, the rough contour process is actually the third process to do the turning operation. So the part A of the third box is gonna be rough contour. So then we'll move to the part B. So part B involves a holder, cutting tool application, boring bar type, and size. And for your information, all the answer that I got for part B is I referred to the appendix that was given by my lecturer. So the holder that I choose is going to be tools indexable holder center / straight / middle, and also the cutting tool that I choose is turning insert carbide cutting tool in the shape of trapezium. So I'm going to explain why I choose carbide is because in turning operation, most of the tools for the operation under turning is going to use the material of carbide, except for the drill process. And then why I chose the shape of trapezium is because the control process will use the tools in the shape of trapezium. And then based on the appendix, the application that I got is dynamic bar copying. The reason why I got copying is because copying is one of the process that under the contour process. And then based all of the answer that I got, the boring bar type that I able to receive is E SDUC-A, and also the size of it will be 23 millimeter. So I'm going to explain how I got this. So for this process, the diameter for the workpiece in the vertical position is going to be 50 millimeter. So when I divided 50 millimeter into 2, it's going to be 25 millimeter. However, in the size of the appendix that was given to me, there is no 25 millimeter of size. So I choose the nearest number to 25, which is 23 millimeter. So that's how I got 23 millimeter. And so we'll move to the part C and also the part D of this process. So in part C, there will be cutter material, cutting speed, workpiece diameter, machine maximum, cutting edges fluids, spindle speed, chip load, and also feed rate, and also estimated time. So the part D is going to be the drawing that I got for this process. So first, for your information, for part C, all the answer that I calculated is using the website that was given by my lecturer. So this is the website that I purchased. So first, as I said earlier, the tools for this process is going to be carbide. So obviously the cutter material will be carbide. And so as soon as I put carbide in that website, the cutting speed will immediately show up, which is 305 meter per minute. And also, as I said earlier in the part B, workpiece diameter that I use is going to be in a vertical position, which is 50 millimeter. And also the machine maximum is going to be 6,000. And in this value, I just follow the example that was given by my lecturer. And so the cutting edges and fluids for this process is going to be 1. It is because in turning operation, they only use single point in cutting edges or fluids. And also, and after I put all of this info in the website, immediately, and I calculate it, immediately it will show the answer for spindle speed, chip load, and also feed rate. So for spindle feed, I got 1940 RPM. For chip load, 0.673 millimeter per revolution, and also feed rate, I'm going to get 1307 millimeter per minute. And also for the next box, which is estimated time, I calculate it by using the formula of length of cut divided by feed rate. So the length of cut that I got in this process is 100 millimeter divided by the feed rate that I received earlier through the website, which is 1307 millimeter per minute. So it shows that after I calculated by using calculator, the estimate time for this process is going to be 0.077 minute. And also that will be done for part C. So part D is going to be my drawing, my sketching for the process, for this process, which is rough contour. Okay, so that will be the end of my presentation. Thank you so much for listening.